There is a moment after the heart stops, after the monitors flatline, when medicine has always assumed the brain goes dark, silent, offline, done. That assumption has guided how we think about death, what we tell families in hospitals, and what we believe happens to a person in their final moments for the entirety of medical history. In 2022, a research team at the University of Michigan placed electrodes on the scalps of 4 dying patients and recorded what the brain actually does, second by second, as a person dies. What they found did not match the assumption. 2 of those 4 patients, in the 30 seconds after the ventilator was removed and the heart stopped beating, showed a sudden, massive surge of brain activity. Not degrading activity, not random noise. Organized, coherent, high-frequency oscillations of the exact type associated with conscious awareness, perceptual experience, and dreaming. One patient's brain spiked to activity 300 times higher than its previous baseline. 300 times! After the heart stopped. Their brains at the moment of death were more active than they had ever been while alive. What they experienced in those moments, if they experienced anything, science cannot yet say. But that it happened is no longer in question. This is what your brain does in the last 60 seconds before you die, and it is one of the most disturbing and extraordinary things that science has recently confirmed. Let's start with what we thought we knew. When a person dies of cardiac arrest, when the heart stops pumping blood, the accepted model was straightforward. Without oxygenated blood, brain cells begin to fail. Electrical activity drops. Within about 20 to 30 seconds of the heart stopping, the EEG flatlines. The brain goes silent. The person is gone. This model is not wrong exactly. The brain does stop eventually. Brain cells do die from oxygen deprivation. The EEG does eventually go flat. But the new research, and it is remarkably new, with the landmark human study published in the Proceedings of the National Academy of Sciences in May 2023, shows that the journey from heart stopped to brain silent is not a smooth descent into darkness. It is, in some patients, the opposite. Jimo Borjigan is a neuroscientist at the University of Michigan School of Medicine. Her primary research area when she stumbled into this territory were circadian rhythms, the science of sleep and biological clocks. In 2008, she was studying how stroke affects the brain's production of sleep hormones. She was monitoring the neurological activity of rats experiencing induced cardiac arrest as a comparison baseline. What she saw on the readout stopped her. "The brain should be going crazy," she later said, which is exactly what happens. In 2013, Borjigan's team published a paper in PNAS that found a transient surge of synchronous gamma oscillations in the brains of dying rats, occurring within the first 30 seconds after cardiac arrest. Gamma waves are the highest frequency oscillations in the brain. They are associated with conscious awareness, perceptual processing, and complex thought. The dying rats' brains did not go quiet. They surged. For a brief window, 30 seconds measured precisely, the neural activity spiked into patterns associated with heightened, organized consciousness. The paper made the New York Times. Neuroscientists were intrigued, skeptical, and challenged. The obvious question was, do humans show the same thing? 10 years of research later, the answer is yes. Some of them do. And when they do, the activity isn't just elevated. It is the most organized, most coherent, most intensely coordinated activity those specific brains were ever recorded producing. The 2023 PNAS study is worth understanding in detail because the details are the most important part. The study was retrospective. Borjigin's team at Michigan Medicine searched their neurointensive care unit records going back to 2014. They were looking for patients who had died while already connected to continuous EEG monitoring, because EEG monitoring isn't routinely done for the purpose of studying death. It is done to monitor brain-injured patients for seizures. The deaths, in these cases, happened incidentally while the monitoring was already in place. They found 4 patients who fit the criteria. 4 patients, all comatose, all dying of cardiac arrest following brain injury or cardiac conditions, all removed from ventilator support by their medical teams and families as part of end-of-life care. When ventilator support is withdrawn from a comatose patient, the heart typically continues for a short period before stopping. It is during this transition, ventilator off, heart still beating, then heart stopping, that the team examined the EEG data. 2 of the 4 patients showed nothing unusual. Their EEG declined as expected and went flat. 2 patients showed something that the research team described in the paper's commentary as paradoxically heightened electrical activity. Patient 1, a woman in her 20s with cardiac arrest-induced anoxic brain injury. When the ventilator was removed, her EEG showed a sudden elevation of gamma power. The spike began within seconds of ventilator removal and remained elevated for a sustained period before the final decline. Patient 3, different profile, similar result. A surge in beta and gamma band activity, concentrated in specific cortical regions. What made these surges scientifically significant beyond their mere existence was where they were happening. Both patients showed the strongest activity in a region called the temporoparietal junction, the junction of the temporal and parietal lobes at the back of the brain, behind the ear. George Mashour, the founding director of the Michigan Center for Consciousness Science and co-author of the study, described this region as the posterior cortical hot zone, a region specifically implicated in conscious perception, visual processing, dreaming, and out-of-body experiences. This is the area that lights up when people have out-of-body experiences. To understand what this brain activity might mean, if it means anything, you need to understand gamma waves. The human brain produces electrical oscillations at different frequencies. Delta waves are slow, 0.5 to 4 Hz. They dominate deep sleep. Theta waves are associated with drowsiness and early sleep. Alpha waves come with relaxed wakefulness. Beta waves with active thinking. And then gamma. Above 25 Hz, sometimes measured up to 150 Hz in the dying brain studies, gamma oscillations are the fastest, most complex brainwaves. When you see something and hear it and feel it all at the same moment as one integrated experience, gamma oscillations are the neural mechanism binding it together. They are the signature of awareness. Now comes the part that science cannot fully resolve. There is a compound produced naturally in the mammalian brain called N,N-dimethyltryptamine, DMT. It is also the active psychoactive compound in ayahuasca, the Amazonian plant medicine used in ceremonial contexts for centuries. In 2013, Borjigin's team confirmed the presence of DMT in the pineal glands of living rats. In 2019, they confirmed its biosynthesis in multiple brain regions, including the neocortex and hippocampus, regions associated with perception, memory, and higher-order cognition. Critically, they found that DMT levels in the visual cortex of rats increase following cardiac arrest. Rick Strassman, a clinical psychiatrist and researcher at the New Mexico University, who spent years administering intravenous DMT to human volunteers in controlled studies, had hypothesized since 2001 that the pineal gland, the small structure deep in the brain that Descartes called the seat of the soul, releases a surge of DMT during the dying process. His volunteers, when given intravenous DMT, consistently reported experiences that were strikingly similar to near-death reports: geometric visual patterns, encounters with perceived entities, an overwhelming sense of moving through a threshold into somewhere else, feelings described as realer than real. Near-death experiences have been reported across every culture and every era of recorded human history. The earliest documented accounts come from ancient Egypt and classical Greece. Plato's Republic contains a detailed account of a soldier named who apparently died in battle and was revived, reporting a journey through the afterlife. In modern clinical settings, surveys of cardiac arrest survivors consistently find that 10 to 20% report a near-death experience. The consistency of what they report is what makes researchers take the phenomenon seriously. Out-of-body experiences, viewing themselves from outside their bodies, often accurately describing events in the room that they had no sensory access to. A tunnel, movement toward a light, a sense of life review, not just memory, but a simultaneous panoramic experience of one's entire life at once. Encounters with perceived entities, deceased relatives, light beings, figures described as deeply familiar despite being unrecognizable, and a consistent, overwhelming quality that the experience felt more real, more vivid, more intense than any ordinary experience of waking life. The 87-year-old patient whose unexpected death in 2022 was captured on EEG at the University of Tartu, Estonia, the accidental recording that preceded the deliberate Michigan study, showed gamma surges in the same temporoparietal hot zone during the 30 seconds before and after his heart stopped. His medical team was not studying death. They were monitoring him for seizures after brain surgery. He died. His brain surged. The recording existed. Steve Jobs' last words were, "Oh wow, oh wow, oh wow." He was looking at something beyond the people in the room. His sister, Mona Simpson, who was present, wrote about it afterward. He appeared surprised by what he was perceiving. Whatever the brain is doing in those final seconds, whether it is a biological alarm system, a chemical response to oxygen deprivation, a final dream, or something stranger, it is producing something that at least some people experience as real, as the realest thing they have ever experienced. And then it stops, and whatever they were experiencing stops with it, or possibly does not. Here is where the science ends and the question begins. We know, with the authority of peer-reviewed research, multiple independent replications, and direct EEG measurement, that the brain does not go quietly. In some people, in the final window, it goes louder than it ever went before. We know the gamma surge happens in the part of the brain that produces conscious experience. We know it involves the same neural architecture that generates dreaming, out-of-body sensations, and vivid visual processing. We know that 10 to 20% of cardiac arrest survivors report experiences during this period that they consistently describe as more real than ordinary life. We know that across every human culture in recorded history, people who have approached death and returned describe a remarkably consistent set of perceptions. We do not know what those perceptions mean. We do not know whether they indicate something beyond the brain. We do not know whether the experience has a subject, whether there is truly a someone having it, or whether it is simply the last pattern the neural machinery produces before it goes dark. The dying brain is not passive, it is active. It is, in its final window, doing something extraordinary. Every person who has ever lived and died has gone through this. Every person who will ever die will go through this. You will go through this. And in those final seconds, when the gamma waves surge and the temporoparietal hot zone fires and the neurotransmitters flood and something happens in the last coherent moments of your brain, you will experience something. Something intense and organized and as real as anything you have ever experienced. What it is, science cannot tell you. But that it happens, that your brain reserves its greatest burst of activity for the moment of your death, that much now we know. Steve Jobs looked at something the rest of the room couldn't see and said, "Oh wow," 3 times. Whatever it was, we have now confirmed, scientifically, that his brain was capable of producing it. The rest is silence. Or possibly not.